So in this video, we're going to look quickly at how to convert between moles and atoms and molecules. So Avogadro's number is not one that you have to memorize. It is a constant that's given to us on our list of constants and conversions in our reference materials. Avogadro's number is equal to 6.02 times 10 to the 23rd. This is Amadeo Avogadro, this guy here. He didn't actually figure out Avogadro's number. We just name it after him because he did some other pretty cool stuff. But regardless, 6.02 times 10 to the 23rd. Avogadro's number is 6.02 times 10 to the 23rd. That's how many atoms or molecules are in a mole. So how many things are in 1 mole of things? 6.02 times 10 to the 23rd things. But if I have a mole of elephants, how many elephants would that be equal to? That would be equal to 6.02 times 10 to the 23rd. That's a lot of elephants. How many cookies in a mole of cookies? 6.02 times 10 to the 23rd cookies. That's also a lot of cookies. We don't generally actually count elephants and cookies in terms of moles because it's more than actually exists. We use this number, which is a very, very large number, for atoms and molecules because they're very, 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 very small. For elephants and cookies, we would talk about a dozen. There are 12 in a dozen. Whoa, I lost an E, dozen. When I'm talking about very, very small things, atoms and molecules, we would talk about a mole of things. So not a dozen atoms, but a mole of atoms. So how many atoms in a mole of carbon atoms? That would, of course, be 6.02 times 10 to the 23rd atoms of carbon. How many atoms of carbon, I should say molecules, sorry, how many molecules of carbon dioxide in 2 moles of carbon dioxide? Well, I can just take my mole number, 6.02 times 10 to the 23rd, and multiply it by 2. Because if I have this many in 1, I'm going to have twice as many in 2. So 6.02 times 10 to the 23rd times 2 is going to give us 1.204 E24. That E tells us that we're looking at scientific notation. E is 10 to the. So 1.204 E24 is the same thing as 1.204 times 10 to the 24th power. That E tells us scientific notation 10 to the 24th power. I can also use my railroad tracks to set this problem up. So my given is 2 moles. I have 2 moles of carbon dioxide. I want to convert my moles to not atoms, but molecules. I have moles on top. I'm going to put mole on bottom. I want to convert my moles to molecules. I know that there are 6.02 times 10 to the 23rd molecules in 1 mole. So our moles on top and moles on bottom cancel out. 2 times 6.02 times 10 to the 23rd. We just did that calculation. It's 1.204 times 10 to the 24th power. This problem is similar, but reversed. So here my given is already in atoms. I have 1.8 times 10 to the 24th atoms of carbon. I want to convert that to moles. Since I have atoms on top, I'm going to put atoms on the bottom. I want to turn my atoms into moles. How many atoms in a mole? How many atoms in a mole? Always, there are 6.02 times 10 to the 23rd things in every 1 mole. Per mole means in 1 mole. I have 1 mole. I have 6.02 times 10 to the 23rd atoms in that 1 mole. I put atoms on the bottom so that these atoms on the top and these atoms on the bottom can cancel out. I'm going to multiply by everything on the top, 1.8 times 10 to the 24th, times 1, divide by everything on the bottom, divided by 6.02 times 10 to the 23rd. 1.8 times 10 to the 24th divided by 6.02 times 10 to the 23rd. Be careful when you divide in scientific notation. Make sure that you either use parentheses around your scientific notation or use that EE button second function on top of the comma, that blue EE on your calculator. Anyhow, we do this math and we get 2.9900, lots and lots of decimal places. I have 2 sig figs. I'm going to keep 1 2 sig figs. That 9 is going to turn that 9 into a 0, which turns that 2 into a 3. So we've got just about 3 moles of carbon atoms. These three, do on your own. Pause the video, come back and check your answers. All right, hopefully you are ready for some answers. This is our given 2.5 moles, 2.5 moles of silver. I want to convert my moles to atoms. I have moles on top, I'm going to put moles on the bottom. Convert my moles to atoms. I know that there are 6.02 times 10 to the 23rd atoms in every 1 mole. Moles on top and moles on bottom cancel out. When we do this calculation, 2.5 times 6.02 times 10 to the 23rd power divided by 1, we get 1.505 E24. Remember that means 1.505 times 10 to the 24th power. Don't lose that scientific notation exponent at the end of your calculator screen. I only have 2 sig figs though, so I'm going to keep 1, 2. That 0 is going to leave that 5 of 5. Our final answer is 1.5 times 10 to the 24th atoms of silver. How many molecules in 0.8 moles of water? So we're going to do this one the same way. I'm going to start with my given. I have 0.8 moles, moles of water. I want to turn my moles into molecules. I have moles on top. I'm going to put it on the bottom so that I can cancel out. How many molecules in a mole? There are 6.02 times 10 to the 23rd molecules in 1 mole. So now my moles on top and moles on bottom cancel out. We're left with molecules, which is good because that's what my question is asking us to find. Calculation-wise, I'm going to multiply by everything on the top, divide by everything on the bottom. 0.8 times 6.02 times 10 to the 23rd power divided by 1 gives us 4.816 E23. You only have 1 sig fig here, so I'm going to just keep this 1, but that 8 turns that 4 into a 5. So my final answer is 5. Don't forget your scientific notation, E23 times 10 to the 23rd molecules of water. 5 times 10 to the 23rd molecules of water. This one, 3.01 times 10 to the 23rd molecules of sodium nitrate. This is my given. We always start with the given. 3.01 times 10 to the 23rd molecules of sodium nitrate. We're going to convert our molecules into moles. Since I have molecules on the top, I'm going to put molecules on the bottom so that they cancel out and turn my molecules into moles. We know that 1 mole always has 6.02 times 10 to the 23rd things like molecules. We put 6.02 times 10 to the 23rd on the bottom because I have molecules on the top and I want it to cancel out with molecules on the bottom. Molecules on the top and bottom cancel out. We're left with moles, which is good because that's what our question is asking us to find. Calculation-wise, 3.01 times 10 to the 23rd power times 1 divided by 6.02 times 10 to the 23rd power. Again, make sure that you either use parentheses around your scientific notation or that EE button. 3.01 times 10 to the 23rd times 1 divided by 6.02 times 10 to the 23rd power is going to give us 0.5. But I have 1, 2, 3 sig figs. I need to keep 1, 2, 3 sig figs. That many moles. If you have questions, you know where to find me.